Okay, the derivative, so this is just your polynomial rules. So the derivative, so f prime equals front times top, so 16 with one lower. And then on the next one, it's a minus 5 with no x's now. And then the last part is a 0. When you derive just a number, it's 0. Number 2, I would rewrite the radical stuff into exponents. So if you have a root 4, that's the same exponent as a quarter. Now, tackle the rules. Front times top. So negative 2/4 or negative a half. Doesn't matter. I'll just write that, but you can obviously have made it negative a quarter or negative a half, sorry. 1 less negative 3/4, yeah. Okay, and don't forget, I guess I don't have an example of this, but like if you see this, make sure you rewrite it with a what before you tackle it? Rewrite it and then tackle it, okay? So just a little side note. Okay, what would you do for the number 3?
Chain?
Not a chain, not a quotient, multiplying rule, the product rule, yep. So we're going to derive the first bracket. So don't worry about that, that's 0. So I have to derive this, so I'm going to go negative 3x to the 1 lower. Are we good with that derivative? Times, just copy the second bracket, plus copy the first bracket, and derive. Okay, the end. I'm not looking for you to go any more. Don't simplify it. It's good. Number 4. We've got division, so now we're going to do the quotient rule. Okay, so I need you to derive the top. Derive the top times original bottom subtract original top derive the bottom numbers are looking good. 8x cubed, all of it divided by original bottom squared. Okay, number 5 is what do you call this one? Chain rule. Okay, so we need 5 of those to the 4th. 5 of those to the 4th. And then you attach the derivative of it in the middle. So it is a 3x squared Good? Number 6, I'm going to rewrite. I'm not going to do that with a radical. I'm going to rewrite with an exponent. Okay, always the theme. If there's a radical, just change it to an exponent. Okay, so this is a chain rule again.
Which one is chain rule on this?
The chain rule is right under the quotient.
1, 2, 4th one?
Yep. So can you see it's like the,
Oh, yeah.
this is the front times the top of that to the one lower,
Oh, yeah.
and then attach the derivative of that bracket stuff. Okay, so here we go. Front times top is 1/2 of the unit. 1/2 of the units to the lower one. You have to go down one. And then attach the derivative of the bracket stuff. Done. Maybe if you saw me on an answer key, I probably would have simplified it, just maybe this part a little bit, but I'm also fine leaving. Okay, on this one, what would you think to start with? You're going to start with a product. Okay, here I go. I'm going to derive my yellow. Derive my yellow. Times keeping my pink. Good, seeing my components so far? Plus, keep my yellow. Here's the hard part. I'm going to derive my pink. But I'm going to have to do a bunch of stuff. Do you see? What am I going to do? 4 of those cubed attach so do you see my components? I have my F times my G prime. It was just a long one. Good? Okay, reading a chart. There's 2 questions on the chart here. Okay, ready? We're going to do a quotient. So I'm going to write this out a little bit abbreviated. I'm just going to go F prime G minus F G prime over G squared. Just a little bit of a shortcut I'm doing. Obviously, it's not, I should have done F of X, G of X. But. Okay, so that's what I'm thinking. And I'm doing this all at the X value of 2. So we're going to read the chart at 2. So basically, I don't know. I'm just going to highlight it so I can see this all. Okay. What's the F prime? So that's a -1. Times an original G, 3. Minus original F, 4. G prime, 1.5. Divided by original G, which is 3, squared. Good? Okay, is that okay on the chart? You're just following the rules and the patterns. Number 9 is the one we haven't used that much. The only time you use this rule is on a chart. I don't think I've ever done one as an equation. So you do the derivative of that and then you attach. So the derivative and then you have to attach the derivative. Okay, so this is at the x value of 6. So the first thing you're going to have to do is to figure out what is just the g of 6. What is the g of 6? So what would you use there? 4. Just the g of 6 is 4. Then, what's the f prime at that 4? So f prime at 4, so that's a -1. And then this is the original, so this is at 6, so what's the g prime at 6? -2. Okay, trig stuff. A couple trig questions. Okay, what is the derivative of a sine function? So we do the cos of it. Cos of the stuff, and then we always attach the derivative of the stuff. Cos of the stuff, attach the derivative of the stuff. Okay, so what's the rule with the cos? Negative sign of the stuff. Negative sign of the stuff. Attach the derivative of the stuff, which is going to be a chain rule. So if I just was deriving this, I would have to do 2 of those to the 1, attach the derivative of it, right? So 2 of those to the 1, attach -6x. Two of those to the one lower, and then attach the derivative of the brackets. Okay, following? Okay, what's the rule with ln's? Flip. So I'm going to do 1 over that stuff. And then I'm going to attach the derivative of that stuff. Okay, some of you might have just done this as the rule, so then it would have been, that's the same thing, right? Okay, what's the rule with E? Just rewrite it. I don't even know what that is. That's so fuzzy. Is it a cubed? 2x cubed? Rewrite it. And then attach. Okay, number 14 is called implicit differentiation. So do you see my equation has x's and y's all happening? So remembering that whenever we're deriving, if we derive x with respect to x, we just don't write anything. And when we derive y with respect to x, we've just been kind of shortcutting it like that. Whenever you derive a variable, when we derive x, we're technically writing this beside it, but I'm just not because it's 1. And when we derive a y, we're doing that. Okay, so here we go. Derive, so that would be 8x, and I did that with respect to x, so no attachment. Deriving makes 6y squared, and I derived with a y, so I have to attach. And then on the last one, 4y would become derived as a 4, but I derived with a y, so I have to attach. Now, your goal is to have units that don't have y primes on one side, units that have y prime on the other, which is already done. So I'm going to y prime GCF. Some of these questions on your test might have at the very end, find the derivative at this point or something. So now you just do this work and plug in the coordinate at the end, right? Oh, well, okay. This one we're going to do is a little bit harder. Okay, so this is 15x squared. And I derived it with respect to x, so no attachment. This, I'm going to have to do a product. Okay, ready? What's the derivative of my yellow here? 1. 1 times the original pink. Plus, whoops, I did that wrong. Plus original yellow, so just the x, times the derivative of my pink. So 2y. Oh, that's a deriving a y, so I have to attach. Equals. You know what I'm going to do again? Another product rule. So there's my yellow and my pink. Okay, so derivative, yellow is 15x squared times original pink. Plus original yellow. Derivative pink is 3y squared, but I've done a y, so I attach. Okay, so now out of this whole thing, I have to identify what units have a y prime in them. So this and that. There's two things that have y primes in them. So we're going to go one way. Let's move this to that side of the equation. And then can I move this? Can I do that? Is that okay? Do you see my organizing?
Why are you moving it?
Anything that has y primes in it
Okay.
is going to have to be on one side.
Okay.
And if it doesn't have a y prime in it, it's going to go on the other side. So do you see my organizing?
Yeah.
I want this with on the same side. Okay, so a couple changes that I made. I wrote this as a 15. Instead of writing a 5 and a 3 separately, I just made it a 15. Is that okay? And then this one, instead of writing with an x times a 2,
Still don't know where you got the 3 from.
this 3
From
right
a
here.
y. You can just multiply it even though it's attached to a y.
Like that. Did you see how I went 3y squared?
No, but like the fact that you multiply
But why
the
do you
five
multiply the
and-
5 and the 3?
Because they're attached to different.
They're all being this times this times this times this times this times this together.
Okay.
Is that okay?
Yeah, I guess.
So if I times them all together, I can combine stuff, right?
If you did it, would it still be fine?
Yeah. And then this one, I just like my numbers in the front, so I went 2xy instead of x2y. That's just all I did. It was just I like my numbers in the front. Okay. Now, can you understand you could GCF a y prime out?
We're gonna be 1 hour on the test.
Yes.
Well, that sucks.
It's a lot of numbers. So you always have to kind of think, where are these numbers coming from, and organizing them.
What if we don't, like, simplify, like, turn that into a 15 from the 5?
It's not wrong, but if you can recognize like a 2x times an 8y or something, you know, then I'm going to go 16xy. Okay. So we are going to write an equation of a tangent line and a normal line. The normal line is the one that's perpendicular. Perpendicular line. Okay, so I need to do a slope. So I get 3x squared minus 6x is my slope equation. So what is the actual slope at 3? At an x value of 3, did I do my Monday mental math right? Okay, so now my tangent line is going to have a slope of 9/1. And it goes through the coordinate 3, 2. And you will have this available on your test. This is all I was doing. Rise, run, plug in the coordinate. No, that's not part of your memory thing, but and then on your test day, I would give you this exact paper on your test day, which has that on the bottom. Okay, so what's the normal line? How do you change the slope? You flip and negate. So the slope would be -1/9, right? Would that make sense if I flip and negate? So -1/9, and then the point is still the same, right? One of the other ways I could be a little bit tricky on this question on the test would be to not give you the coordinate of the point and just give you the x value. So what do you do if I just give you x? Plug it into the original, yeah, original, right? Like if I just said, instead of giving you the coordinate, what if I just said at x equals 3? What would you have done? You would have plugged a 3 in to this original.
How would you do it if it was the slope of negative 9?
If the original slope was negative 9, so then this would have been a negative 9 and a 1, and then this would have been a positive 1 and a 9. Is that good? You see?